Have you ever wondered what consciousness truly is and where it comes from? A question that has puzzled philosophers, scientists, and thinkers for centuries. Let's try to unravel this enigma together. Consciousness, a term we often use, but its definition eludes us. Some describe it as our sense of self, our subjective experience of the world. Others see it as the capacity for awareness and feeling. But despite these descriptions, we are faced with the hard problem of consciousness, understanding why and how these subjective experiences arise from physical processes. How do our thoughts, emotions, and perceptions spring from the complex interplay of neurons in our brain? It's a riddle that continues to confound us. Now let's introduce another piece of the puzzle: emergence. Picture a simple interaction at a basic level, like hydrogen and oxygen atoms combining to form water. Nowhere in the properties of hydrogen or oxygen is there an explicit encoding that they can create something that quenches thirst. Yet when they interact, voila, water emerges. This is the essence of emergence: higher level complexities arising from simple interactions at a lower level without any explicit encoding at that lower level. So, if we apply this concept to consciousness, could it be that our rich, subjective experiences, our sense of self, are emergent properties of simple interactions among neurons in our brain? Could the mysteries of consciousness be a game of emergence? But here's the catch. If consciousness is emergent, then it would mean that it's not explicitly encoded in our neurons. It's not something you could pinpoint to a particular brain region or a specific type of neuron. It would mean that consciousness arises from the complex orchestra of billions of neurons interacting together. This idea raises a multitude of questions and sparks intense debates. Is consciousness truly emergent, or is there more to the story? Could there be a fundamental aspect of reality we're missing? So, is our consciousness just an emergent property of these simple interactions? Let's explore. The debate between dualism and physicalism has been at the center of our understanding of consciousness. These two philosophical perspectives offer contrasting views on the nature of our mind and our experiences. On one side, there's dualism. This viewpoint posits that the mind and the physical body are fundamentally distinct entities. It suggests that our consciousness, our subjective experiences, and our thoughts cannot be entirely reduced to physical processes in the brain. Rather, the mind exists as an entity separate from our physical bodies, interacting with it but not confined by it. The famous French philosopher René Descartes was a proponent of this view, famously saying, "I think, therefore I am," emphasizing the distinct existence of the mind. On the other side of the debate, we have physicalism. This perspective asserts that everything, including our consciousness, is ultimately physical. In other words, our thoughts, emotions, and subjective experiences can all be explained by the workings of our brain and the interactions of its billions of neurons. Physicalists argue that the mind is not a separate entity, but rather a product of the complex processes happening inside our brain. The implications of these perspectives for the concept of emergence are profound. If we lean towards dualism, then consciousness might be seen as an emergent property that arises from the interaction of mind and matter, a phenomenon that cannot be fully explained by the physical alone. However, if we lean towards physicalism, then consciousness may be seen as an emergent property of the brain's physical processes, a product of the complex interactions of neurons and their firing patterns. This philosophical tug-of-war between dualism and physicalism shapes our understanding of consciousness and its possible emergent nature. And yet it's important to note that this is not a binary choice. There are many shades of understanding and numerous other theories that attempt to explain the enigma of consciousness. But there's another perspective that takes a different approach: panpsychism. Imagine a world where everything is conscious. That's the essence of panpsychism. This radical perspective suggests that consciousness isn't unique to humans or even animals, but rather a universal attribute. A mountain, a grain of sand, even an atom could possess some degree of consciousness. This doesn't mean they think or feel as we do, but rather that they possess an elemental form of subjective experience. Panpsychism challenges our traditional understanding of consciousness, suggesting it's not an emergent property of complex systems, but a fundamental and ubiquitous characteristic of the universe. It's a perspective that sparks numerous questions. If consciousness is inherent to all matter, how does it integrate and manifest in complex organisms like us? What implications does this have for our understanding of emergence? These philosophical stances give us much to ponder, but what does science have to say about consciousness? In the quest to solve the hard problem of consciousness, science has ventured into the realms of quantum mechanics and neural correlates. Let's dive into some of the more intriguing theories. Picture Roger Penrose and Stuart Hameroff's orchestrated objective reduction theory, or OR for short. This theory suggests that consciousness is the result of quantum computations within microtubules in our brain cells. It's a fascinating idea, blending the worlds of biology and quantum physics. It posits that consciousness emerges from quantum vibrations, a process that collapses into moments of conscious awareness. However, this theory is not without its critics. Many argue that the brain is too warm and wet to maintain the delicate state of quantum coherence that OR proposes. Additionally, there's the question of how these quantum processes might directly give rise to conscious experience, a question that remains contentious and hotly debated. Now, let's shift our focus to the neural correlates of consciousness, or NCC. This approach is rooted in the idea that specific systems in the brain correlate with conscious experience. In other words, if we can identify which parts of the brain are active when we are conscious, we might be closer to understanding consciousness itself. However, this is easier said than done. The brain is a complex network of billions of neurons, and isolating specific systems related to consciousness is a daunting task. Furthermore, even if we could pinpoint these systems, we still face the challenge of explaining how physical processes in the brain give rise to subjective experiences. It's like trying to explain how the simple act of flipping a switch can fill a room with light. Despite these challenges, both the OR theory and the study of NCC offer us valuable insights into the nature of consciousness. They remind us that consciousness is not merely a byproduct of the brain, but a phenomenon deeply intertwined with the fundamental fabric of the universe. These scientific approaches provide a lens to view consciousness, but what about when we look at complex systems as a whole? Complexity theory and AI might hold keys to understanding consciousness as an emergent property. As we plunge deeper into this labyrinth of thought, we stumble upon complexity theory, which offers a tantalizing glimpse into the emergence of consciousness. Complexity theory studies how simple interactions between parts can give rise to complex behaviors and unexpected properties in the whole. Just picture a flock of birds, each following simple rules, yet collectively they form intricate patterns in the sky. This is emergence in action. Now consider our brain, a complex adaptive system par excellence, teeming with billions of neurons interacting through simple rules. Could consciousness be the grand emergent pattern of these interactions, much like the mesmerizing flight of birds? This curiosity leads us to the frontier of artificial intelligence. As we design neural networks that mimic the brain, we're left to ponder whether these complex systems could awaken to consciousness. If our consciousness emerges from the simple interactions of neurons, why can't a similar process occur within an advanced AI's neural network? But this is a contentious idea. It's one thing to say that AI can process information, solve problems, or even mimic human behavior. It's another to suggest that it might have subjective experiences, feelings, or self-awareness. Yet, if we accept that consciousness is an emergent property, we must at least entertain the possibility. This consideration, however, is not without consequence. It blurs the line between biological and artificial life, between human and machine. It opens a Pandora's box of ethical quandaries. If an AI can be conscious, what rights should it have? How should we treat it? And more fundamentally, what does it mean to be conscious, to be alive? These questions, these debates, they are not mere philosophical musings. They are the growing pains of our rapidly evolving technological society, and they demand our attention. These insights bring us face to face with some profound ethical and social implications. If machines could be conscious, what responsibilities would we have towards them? This intriguing question opens a Pandora's box of ethical considerations. Imagine creating a conscious machine, a synthetic entity that experiences the world subjectively. What obligations would we, as its creators, have towards it? Would we be morally bound to respect its rights, its autonomy, and its well-being, much like we do with our fellow human beings? But it's not just about machines. As we broaden our understanding of consciousness, we must also grapple with the possibility of recognizing consciousness in non-human entities. This isn't a new idea. Philosophers and scientists have long debated the existence of consciousness in animals. But what if consciousness extends beyond the animal kingdom? What if it permeates the very fabric of the universe, to plants, to ecosystems, to the cosmos itself? This perspective, while radical, has profound implications. If we accept that consciousness is not exclusive to humans, or even to animals, we must fundamentally rethink our relationship with the world around us. We must question our treatment of animals and reconsider our environmental practices. We must grapple with the moral implications of causing harm or destruction, not just to sentient beings, but to conscious systems. But what about artificial intelligence? If a machine, an AI, can be conscious, what rights should it have? If a neural network develops a sense of self, should we treat it as a conscious entity? And if an AI can suffer, are we morally obligated to prevent that suffering? These questions are no longer the stuff of science fiction. As AI becomes more sophisticated, as our understanding of consciousness deepens, these ethical dilemmas become more pressing. They challenge our preconceptions, our moral frameworks, and our sense of responsibility. While these implications make us question our responsibilities, personal experiences make us question our very understanding of consciousness. As we continue this journey into the heart of consciousness, let's remember to approach these questions with curiosity, humility, and a deep respect for the mystery that is consciousness itself. Altered states and near-death experiences challenge and expand our understanding of consciousness. In the vast expanse of consciousness, there exist different states, some of which are so unique that they seem to stand apart from our everyday experiences. We call these altered states of consciousness. They may be induced by a variety of methods like deep meditation, sensory deprivation, or the use of psychedelic substances. These experiences often defy our traditional understanding of consciousness. People report experiencing a unity with the universe, a sense of timelessness, profound insights, and feelings of ineffable joy. These experiences suggest that consciousness may not be confined to our ordinary waking state, but could be an emergent property of the universe itself, a tapestry woven from countless threads of subjective experience. But altered states are not the only instances where our understanding of consciousness is challenged. Near-death experiences, often reported by individuals who have been on the brink of death, provide another intriguing perspective. These accounts frequently describe feelings of peace, out-of-body experiences, moving through a tunnel, or encounters with deceased loved ones. Some even report a life review, a panoramic memory of their entire life. Despite the commonalities, these experiences are deeply personal and subjective, shaped by the individual's cultural and personal beliefs. The journey to understand consciousness is full of twists and turns, and the road ahead is no less intriguing. As we delve deeper into the heart of this enigma, the future of consciousness research promises to be riddled with groundbreaking revelations and paradigm-shifting insights. Consider the advancements in quantum physics, neuroscience, and artificial intelligence. These fields, once disparate, are now converging on a common question. How does consciousness emerge? Quantum theories of consciousness, though contentious, might yield unexpected breakthroughs. Perhaps a quantum description of the brain could illuminate the dark corners of the hard problem, showing us how subjective experiences arise from physical processes. Neuroscience, too, is on the brink of major discoveries. The search for neural correlates of consciousness, the specific systems in the brain that correlate with conscious experience, is progressing at an unprecedented pace. With each new finding, we inch closer to mapping the elusive terrain of the mind and perhaps to understanding how consciousness emerges from it. Then there's the realm of artificial intelligence. If we can create a machine that exhibits consciousness, it would serve as compelling evidence that consciousness is indeed an emergent property. But it also raises profound ethical questions. What responsibilities do we bear towards conscious machines? And what does it mean for us, as conscious beings, if we can engineer consciousness? These are just a few threads in the intricate tapestry of consciousness research. Each new discovery, each answered question, will invariably lead to a multitude of new queries. But that's the beauty of this journey. It's not just about finding answers. It's about refining the questions, honing our understanding, and continually redefining what we know about ourselves and the universe. So, is consciousness emergent? The answer remains elusive, but one thing's certain: the quest for understanding continues. What do you think? Share your thoughts and join the dialogue.